Next sample problem. A scientist isolates 2.366 grams of a gas. The sample occupies a volume of 800.0 milliliters at 78 degrees Celsius and 103 kilopascals. Use these data to calculate the molar mass of the gas. Is the gas most likely to be bromine, krypton, neon, or fluorine? So, first off, point out the information you got. All right, so what is you're given? Okay, so extract the numbers that are important, and ultimately, we're trying to find what? What are we trying to find? Because we're being asked to compare it. We're trying to find molar mass, ultimately. So we need to find the molar mass of this gas. We don't know what the gas is. But based on that molar mass, we can figure out the molar mass of all these other gases. Bromine, krypton, neon, and fluorine. Now, keep in mind, something I explained to you guys back in the chemical reactions, right, the balancing equations, something I pointed out last year during the chemistry component. Bromine. If we're referring to bromine in a chemical reaction, what is the formula for bromine? And now, the other one to also keep in mind is bromine and fluorine only. They're diatomic. So when you're trying to find the molar masses of these four gases, keep in mind that bromine, we're not just going to write Br, we're going to write Br2. When we're trying to find fluorine here, we're not just writing F, but F2. And neon and krypton, they're not part of the diatomics. So we don't have to worry about those. Those are just, find whatever the molar mass is of those ones. Okay, so take a moment and see if you can formulate an answer from here. Our givens. Pressure, 103 kilopascals. Our volume, 800.0 milliliters. The mass of this gas that was isolated was 2.366 grams. Our constant, 8.314. Our temperature, 78 degrees Celsius. And which, in fact, we're going to have to convert. So there are a couple of things we're going to need to convert. Okay, so our temperature, we know, 78 degrees Celsius to Kelvin works out to 351 Kelvin. The other set of units that need to be converted are what? Volume, right? Because we always want our volume in liters. And here's the hint. If you look at your constant, notice how your constant includes liters. So make sure that your volume, right, are going to be also in liters. So our volume is 0.8 liters, but we've gone 4 significant digits. So try to keep the 4 significant digits running in your steps. You don't have to. It's not going to really make any difference in your final answer, but you just don't want to mistake the number of significant digits into thinking that, oh, I've only got 1 now. Okay. So we've got the equation. PV is equal to nRT. So what are we trying to find? N, right? The number of moles. So we want to isolate for N because once we find N, we've got the mass, right? We've got the mass. What are we going to do between these, the mass of N? We're going to divide, right? To find what? What are we going to find? The molar mass. And then we're going to compare the molar mass that we find with the molar mass we'll be able to find of. So this is going to take all this extra work unless you happen to find the right one, right? So if you're working out bromine and that happens to be, you know, the molar mass that you need, well, then you're in luck. Then you didn't have to calculate the other ones. So we're going to isolate for N. Just a different color here. So N is equal to PV over RT. So our pressure, 103 kilopascals. multiplied by our volume, which is 0.8000 liters, divided by 8.314 kilopascals per liter per mole Kelvin, multiplied by our temperature, which is 351 Kelvin. So we start canceling out. We know what units we should have here at the end, right? And that's moles. So when we multiply all that together, we should get a number of moles of 0.028236 and a whole bunch of others. Okay, so there's the number of moles. We've got the number of moles. We've got the mass. So we can use those to find the actual molar mass of this gas. So we've got the end value, 0.028236 moles. We're going to divide it by the mass here, the other way around, sorry. So 2.366 grams divided by 0.028236 moles. So we take the two numbers, divide them together, and we get 83.79 grams per mole. So we need to find the actual molar mass. Question, least number of significant digits is 3, so the 83.7 becomes 83.8 grams per mole. So we've got the molar mass of this unknown gas, right, that this scientist has isolated. Now, what we need to do is we need to find the molar mass of the four to figure out, is it bromine, krypton, neon, or fluorine? So we need to find the molar mass of bromine, molar mass of krypton, molar mass of neon, and the molar mass of fluorine, right? So it's really important that you were able to isolate or figure out that you needed to know about the diatomics and remember the diatomics, because otherwise we would have just found the molar mass of just one bromine and one fluorine. So let me give you the calculations. So bromine would have given you 141.8 grams per mole. If you found the molar mass of krypton, you would have gotten 83.8 grams per mole. So right away we would have found it on our second attempt. So just for argument's sake, molar mass of neon, 20.2 grams per mole. And lastly, fluorine, 38.0 grams per mole. So we wanted to also make sure that none of the others actually came out to that. And so right away we know what is the unknown gas. It was krypton. Because both of these numbers match up. Okay.